This is Bettina Belises and Lilia Gegutaske's Algebra 2's project.
First, we're going to read you our problem. So, every day, Miss Everdeen needs a dietary supplement of 4 milligrams of vitamin A, 11 milligrams of vitamin B, and 100 milligrams of vitamin C. Either of these two brands of vitamin pills can be used. The X brand, which costs 60 cents per pill, or the Y brand, which costs 80 cents per pill. The chart below shows the pertinent nutritional information for each brand. So Ms. Evergreen is concerned about getting the most for her money. So we're trying to figure out how many pills of each brand should she take every day in order to satisfy her minimum daily need most economically. So we have defined our variables. X will represent the number of X brand pills, and Y will represent the number of Y brand pills.
So our first constraint is the amount of vitamin A needed. Our second constraint is the amount of vitamin B needed. Our third constraint is the amount of vitamin C needed. The reason why constraint number 4 and 5 are greater than, or equal to 0 is because there's no such thing as a negative pills in the real world.
In order to make it easier for us and make it easier to graph these constraints on a graph, we have simplified them. So we've simplified the first constraint to what you see over here, and then the second constraint over here, third constraint over here, and the fourth and the fifth one we didn't have to simplify. We simplified these constraints by basically isolating the Y variable and moving everything else to the other side of the inequality. These are our constraints graphed. So the area where all 4 of the constraints overlap is called the feasible region. Now, in this case, our feasible region extends on forever. And Miss Everdeen doesn't have a maximum amount of pills she can take. But the less pills she takes, the more money she saves, which is why these 4 corner points will be one of our solutions, because they are the minimum amount of pills she can take.
So our objective function is f of x and y is equal to 0.6x and 0.8y. We already know that x represents the number of X brand pills, and y represents the number of Y brand pills. The numbers 0.6 and 0.8 are the prices of each pill. By using this objective function, we can figure out how many pills Miss Everdeen needs each day to satisfy her minimum needs most economically.
So Our solution has two options. So based on our answers, Miss Everdeen should either take 1 pill of the X brand and 2 pills of the Y brand, or she can take 3 pills of the X brand and half a pill of the Y brand to satisfy her daily needs most economically. The total would be $2.20 every day for her pills.
Now we're going to optimize the solution to a different corner point. The corner point that we chose is 0 and 4. This point result is the most expensive price for the pills. So we're going to change the function to make this point the cheapest. In order to optimize this point, we have to change the prices in the objective function.
In order to optimize the 0.04, we're going to need to change the prices of our original objective function. We increase the price of the X brand pill from 60 cents to $5. And then we decrease the price of the Y brand pills to 80 cents to $1. 10 cents. Now Miss Evergreen needs to take no X brand pills and 4 Y brand pills in order to satisfy her needs most economically. The reason why we changed the price of the X brand pill to $5 and the Y brand pill to 10 cents is because the 0.04 only requires 4 of the Y brand pills. And if we have the Y brand pill cheaper, the total will be cheaper. And any other point that has the X brand pill in it will become a lot more expensive.